Okay, hi everyone. Thanks for joining today. Today we will be presenting expert tips to successfully control effect finishes. Presenting today is Tim Mao, our Applications Engineering and Technical Support Manager. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions, please use the questions function on the GoToWebinar panel. Tim will have time to answer a couple at the end. If we don't get to your question, we will be sure to follow up. Finally, this webinar will be recorded and you'll receive a link so that you can review the webinar at your convenience. So with that, I'll turn it over to Tim to get things started.
Thank you, Robert. Welcome, and hopefully we are ready to share with you some exciting information about measuring effect finishes. And so let's go ahead and dive in. We're going to start with talking about why we need a multi-angle instrument. When we talk about effect finishes or metallics or pearlescence or any of those, why is it that a multi-angle instrument is really necessary? Well, first, it's about the things that we're measuring. What some people might call metallic colors. When we're talking about that, we're talking about colors that have sparkle in them. Typically, these metallic colors are made by putting aluminum flake inside of them. And that can happen in an automobile. Obviously, is probably one of the higher use cases for what we're talking about today. But it's certainly not the only place. The shampoo bottle you're using may have some effect. Things are sparkle going on inside of it. You know, your washer, your dryer, your kitchen appliances, small or large, the cosmetics you're using, any of those things may have various effects going on inside of them. So metallic colors have sparkle, and they typically have something that we call flop, which is, we're talking about if you take a sample and tilt it toward your face and then tilt it away from your face, you see the description of flop is typically talking about it getting lighter or darker as you tilt it toward or away from your face view. Okay, so metallic colors have a sparkle and a flop. Effect colors, I put these in quotes because there's lots of different ways people describe these things. Typically talking about things that are hue shifting. So now instead of just it getting lighter or darker as I change my viewing angle, I may see it go from red to green to yellow or other colors in between. Who knows, right? Some of them get pretty wild and can have a large change in the hue that's going on. And we have what we call multicolored, where you're literally looking at a sample, and because of the effect pigments that are in it, you see multiple colors simultaneously. And then, of course, as you change viewing angle, each of those multiple colors may be changing. So we're hue shifting, we may be talking about the entire panel or the entire sample shifting from being blue to purple to red. Multicolor, we may see all the colors of the rainbow at the same time, and as we shift our angle, each of those individual locations that was one color is now a different color. So those effect colors become even more complicated, if you will, when we're trying to measure them. And they may include things like micas and pearlescence and xerolic pigments, but they may also be a mixture of those with the aluminum flake that's in a metallic. And so very quickly we get very, very complicated colors to measure. So ultimately we can boil all that down and say it's any object that changes color based on viewing angle. If I look at that same thing from multiple angles, I get different answers: lighter, darker, hue shifting, more or less chromatic, more or less sparkle, all those kinds of things. That's why we need a multi-angle instrument. Now, portable multi-angle instruments have been around for over 25 years. And today what we're going to talk about is not specifically how those instruments measure those different angles, but we're going to talk about the challenges that come with a multi-angle instrument. Because we're trying to measure all of those things at various angles, we've got maybe some extra challenges that don't exist in measuring other colors. So first of all, of course, we're going to want something that's easy to use because we want to be able to measure, see the data of the multiple angles easily, have it be easy for me to operate the device and so forth. Positioning of the instrument is very important. As you can imagine, because we're talking about an effect color, it changes as I change angle, which means the positioning of the instrument on that becomes very, very important for me to be able to do a repeatable measurement. I may have difficult to measure surfaces, right? Let's face it, if I'm talking about an automobile, there are no flat spots, period, in the typical automobile. And some of them get really, really complex. And I may need to measure a mirror housing or inside of between the spokes, if you will, of a wheel, and those kinds of things. And that can make things very difficult. I'm going to want on-screen details in my instrument so I can enable myself to take action. If I have an instrument that just tells me it's good or it's not good, well, as long as it tells me everything is good coloristically, I'm happy. But when it says something's not good, I need something to help me know what's wrong so that I can look at what it takes to fix that. A lot of these instruments are used in production environments, right? And so anytime I need to go calibrate the instrument or that I have to spend charging the battery because I'm using the instrument constantly, those can be drawbacks, right? And I want agreement between my instruments so that if I have 4 instruments in my plant, I know that I can be confident that they all read the same. And if I have 4 different plants where I'm doing measurements, that all the instruments in all those locations can read the same, whether they're new or they're legacy instruments. So this is all leading us to start to talk about this instrument called an MA-5 QC. It's new, it is, but we're also going to talk about the existing devices a bit. So let's dive in. So this instrument, an MA-5 QC, is the most compact and lightest. And I'm going to show you a little video in a minute that will help you understand about its size. Lightest, the instrument weighs just over a pound. You can see in this photo here, this happens to be my car and my hand holding the instrument, measuring. And we did a series of photos and videos and for various marketing purposes. I can tell you I was holding that instrument for several hours doing measurements. With it being as light as it is, my hand didn't get tired. There wasn't any issue with that. Accurate positioning on the tightest intersections, and let me show you a different photo. So this is the instrument actually sitting on, this is a sample plastic substrate that's used to do testing on, but it's not uncommon for an automobile or for a part or something you're measuring to have those kinds of things where it's got a bend and a corner and so forth. The instrument's small enough and precise enough to be able to fit in there. It actually can go between, if you have like a 5-spoke wheel, automotive wheel, we can fit between them in some cases and actually measure the color in there. It's fast in the way that it does measurement, and it's an intuitive touch screen. And basically what that means is we all have smartphones. The instrument works the same way. We'll show you a bit about that as well. And it's programmable, allows us to set up the device so that the device is going to tell me if I'm doing, again, in the automotive world, if I'm going to go around an automobile and measure multiple locations, the device can walk me through that. It can tell me on screen where I'm going to measure, where I need to measure next, and then I go ahead and do the measurement. So let's take a look then at me actually measuring a panel with this device. It's a very quick video, but I think it tells us a couple of good stories. One is, you can see the size of that instrument compared to my hands. I tell people when they look at this, it looks like I'm some kind of person with extremely large hands. The reality is that my hands are average or small in size. And the panel that's being measured there, to give you a frame of reference, the direction that you can see easily going from right to left is 6 inches. And the other direction is 4. So the instrument is essentially smaller its footprint is smaller than a 4-inch by 6-inch panel, and easily held by one hand, easily used to do measurements very, very nicely. So we can get a good measurement, but then there's other things we need to do. One is that we want automated, easy jobs, and we'll talk about that, and quick compare. So this is the main interface of the instrument, just to show you. So that icon in the upper left is a job. That's the programmable part, where we could have programmed it to tell us which locations we want to measure, whether that's an automobile or a part or a series of measurements that we always want to do the same. It can walk us through that. But, and that requires that I would have software where I've set up the job and sent it to the instrument, and it's a fairly complex workflow. At the same time, the icon on the upper right is quick compare. I can use that without any software whatsoever. So if I have one color and I want to compare it to another, I simply click that icon, measure the first one, measure the second one, and it will give me comparison data between those two measurements. So while we can do the more complex entire kind of workflow that fits maybe better in some production environment, we also have the ability at any point, and for some people this is the only way they may use the device, to do a quick compare. And I can store the standard so that all I have to do is pull the standard up and hit a measurement and compare my sample to my standard. Very easy to use. The device has LED indicator lights on it. So this is what the screen of the instrument looks like now. If I'm taking a measurement, you'll see those 3 green circles. Those are actual indicators of pressure. So there is a pad or a piece on the bottom of the instrument around where the instrument is taking its measurement that records that I have the instrument properly seated against the sample. If you think about it, we're doing multi-angle measurements, and so any misalignment of the instrument to the sample can change the angles, which of course could make my readings vary greatly if I'm not consistent. So those lights will actually turn, they're red if they aren't properly pressed. Well, at first they're off if it doesn't detect any contact with the sample at all. As I begin contact, they'll turn red, and then they turn green when they're properly seated against the instrument. And as long as they remain green throughout the measurement process, which is 2.5 seconds roughly, the instrument is good. Should I move my hand or change the pressure during measurement, they're going to switch to red, and it's going to stop me from producing a poor measurement, which could have issues with correlation to previous measurements. There's also a temperature sensor. You may have noticed that. It's actually reporting to you on the screen and recording with every measurement the temperature at the point of measurement. Now, why is that important? Well, every color on planet Earth is what's called thermochromatic. Simply means as temperature changes, the color changes, okay, to our eye as well. If we were able to look at a ceramic tile, let's say, nice bright red ceramic tile, and we could see the same exact tile at 2 very different temperatures, let's say 20 degrees C and 30 degrees C, we would visibly be able to see a large color difference between those two, between that same tile at 2 different temperatures. And different colors are affected by this at different rates. Some colors are very thermochromatic, they change greatly. Some change at a very, very low rate. But the fact is everything is thermochromatic. So having that information can really help you. Again, remember we want actionable things. So if I go and get a color difference now on something that I previously measured and I wasn't getting as big a color difference on, maybe I have to look at the temperature, which is saved and recorded with each measurement to help me identify why am I getting a difference. That can really help with the why am I not passing. Again, said it before, if our instrument, our software, our whole process is telling you that you're passing your tolerances, the device is fabulous and there's nothing you really need to worry about. But where we can really provide you value is when you're taking a measurement and the data that's coming back to you is not a passing set of data. We want to give you actionable things that you can look at, and so this temperature adds to maybe a possible cause of why. We've got pass-fail tolerancing. In this particular example, we're looking at a measurement that was done in quick compare. You can see there's 5 angles of delta, L, A, B, and E data there. You can see that it's recorded what temperature that measurement was taken at down at the bottom. Some of those are in green. That's because those values are within the tolerance. Now, the 15 degree you can see is showing in yellow because it's nearing a failure state. If I had to guess, I don't remember exactly, but this probably has a tolerance of a delta E of 1.0 with a warning level set at 75%, which would mean everything is going to be green if it's between 0 and 0.75. It's going to be yellow if it's 0.75 to 1, and it's going to be red if it's greater than 1. That yellow, again, is an actionable thing. We're telling you that you've got a color, not that's failing, but that's getting close to failing. If everything's green, you probably don't have to worry about anything, but if everything's been green and you start to get some yellows showing up in measurements, it might be telling you that something is starting to drift in your production, and you need to focus and correct it before you get to failure. Let's not just deal with failure. Let's stop the failure before it gets there. And of course, we've got a USB connection to software, which can do much more complex things like this, where we've got all kinds of graphing of data, reporting of data. We can filter the data based on various parameters and so forth. We're not going to spend any more time really talking about the software, but just want you to be aware that we do have the ability to go do those kinds of things in our software. All right, moving on. I've got another quick video to show you. This is of me measuring the car. I may run it a couple of times because there's a couple of things worth looking at here. So you can see it go up. You can see the lights went from red to green. You can see it take a measurement, and now I'm actually looking at the screen afterwards of that measurement. That went through really quick, but there's a couple of points in there I want to show you. So right here, I'm just going to kind of drag this. You can see the device. You can see that there's one of the LED lights is red. Okay. As I get it positioned, you can see that the lights will change out of that. And you see my thumb. There's a button underneath my thumb actually squeezing. There's a button on the side right there. That's how I trigger a measurement. And then this whole light is turning green as the measurement is going on, so I can recognize the time it takes to do a measurement. And then once I'm done with that, I have a screen. In this case, kind of blurry when I stop it like that. Sorry about that. I'm only looking at 3 angles. That's fairly common. Most people don't tolerance more than 3 angles worth of data on a multi-angle instrument. I happen to be looking at a 45, 25, and 75 tolerancing. It's still going to report data for me for 15 and 110, but you can see it's not red, green, or yellow to indicate pass or fail because it's basically being collected for reference, not being used to determine pass-fail in this case. So again, great data. You can see that sample up there says RF bumper, right? So that would be that I was running a job that told me to measure the right front bumper, and then when I take the measurement, it's identified that measurement as the right front bumper of where I was on the vehicle when I took the measurement. So ensuring best performance. So a 21-day calibration interval. And I'll be honest, when I first saw that as well, I thought, okay, well, we only have to calibrate once every 21 days. Big deal. Well, if you consider that most multi-angle instruments take, on average, it's 5, maybe even 6 minutes to calibrate because they have all of them, all multi-angle instruments, have fairly robust calibration routine. If I'm running a 24/7 shop, most multi-angle instruments have to calibrate at least every 12 hours. So that's twice a day. I'm going to spend time doing that. Well, if you calculate that out over 21 days, With the MA-5 QC, I'm going to calibrate once. That's 5 minutes. With the other multi-angle instruments, including previous multi-angle instruments from X-Rite, I'm going to spend 3.5 hours doing calibration. When you start to add that time up in 3 weeks, 3.5 hours, and extrapolate that out, it's a significant amount of time. So that calibration really does help us at a lesser interval. Now, that's the external calibration. There's also an internal calibration. There's a calibration tile inside the instrument that is being validated internally to ensure we aren't drifting out of calibration. That's how we can go to 21 days without having to do an actual internal or external calibration. That internal calibration happens without you ever having to do anything. So it doesn't consume any time. The instrument also uses LED illumination, which gets us a couple of things like 2,000 measurements per battery charge. And so that stops us from the problem. Again, a lot of these multi-angle instruments are used in production environments. You don't have something to plug them into while you're using, so you're relying on the battery. And there's nothing more frustrating than the battery deciding to be done or out of power at a time when you need to be doing measurements, and you've got to wait for something to charge up, or hopefully have second batteries and all that kind of stuff. With LED illumination here, it's 2,000 measurements per battery charge, and we are charging it via USB. You can do it with a docking station, and so here you see the instrument's actually slid into this docking station, which is just a USB connection to a PC, or essentially any kind of charging wall charger that will accept the USB connection, like you would use for an iPhone or a smartphone of any kind. You can plug in and charge the device very easily. The docking station's nice because it will also, when it's in there, allow me then, if I want to, upload data back to the software. And it's got a nice clear little cover on it to keep the instrument clean while it's not being used. Okay, we talked earlier about it's important that we have good inter-instrument agreement, and we do. We've got optimized agreement between these devices. So between multiple MA-5 QC instruments, we're talking about a 0.18 delta E average on BCRA tiles. There's also a metallic color or two, I believe, that are tested in that. Okay, so that's the amount of difference between instruments that you can expect, which enables us to use digital standards. And we've actually gone beyond that. So we tested on 196 different paint panels that included solid colors, metallic colors, and pearlescence. Okay? And we tested multiple instruments, and we achieved 95% of them are within 0.16 delta E of each other. Okay, looking at what's called the 45-degree angle, or the face angle, which is the most commonly used angle for tolerancing and for color evaluation. So we're 0.18 on tiles, but we're 0.16 on 95% or more on actual metallic panels agreement between these instruments. So we've got confidence that you can use these instruments to share data between the instruments and be able to have confidence in the results. Okay, so that's between all new devices, but we've also got legacy compatibility and legacy data that's compatible with some previous models. The MA-68-2, which is the instrument on the left, that goes back 25 or so years. There are many of those still out there in the world, right? The MA-94, which was the next generation, was an instrument that's actually slightly larger than the MA-68-2. And then we have the MA-5 QC, the newest instrument. All three of those instruments are 5-angle instruments. They're measuring the same 5 angles. And we have, again, tested across those 196 paints to validate that we have good data correlation through the legacy. And the reason that's important is you may be using some MA-94s and need to add to your fleet, or you may be using MA-68s and need to add to your instrument, right? We can bring an MA-5 QC in there we can use it in correlation or in conjunction with those instruments and continue your measurement program by adding a new MA-5 QC instrument. Side note there, the MA-5 QC instrument actually has a mode that allows it to emulate an MA-94, or which gives us, doesn't change the way it reads color. What it does is it allows this instrument to also connect to those versions of software you may be using with either of these older instruments, to really enable you to buy a new instrument, bring it into your current workflow, plug it in, and keep right on going like it's one of the other instruments, but with all the advantages of that new instrument design, size, and everything. So if you want to learn more, go to www.xrite.com. We've got some great things there. I'm just going to show you a couple quick screen grabs. One is there's a full video you can access that shows us doing multiple measurements with the device and so forth. There's also some brochures there that are useful in talking about use cases, application briefs on using instruments and those kinds of things. Lots of good stuff there for you to access.